Welcome back, mathematicians. In this video, we are going to do more examples where we are finding the domain of functions. In our first example, we are given the function f of x is equal to the expression x minus 3 divided by the expression the square root of x plus 1. So our goal is to figure out what values does our function not accept, or we think of what values our function does accept. Well, in this case, we notice we have two things happening at the same time. So first of all, we see that the square root of x plus 1 happens to be in the denominator of a fraction, which means that we cannot allow that to be equal to 0, because we cannot divide by 0, because that would be an undefined function or undefined ratio. So that's number one. Also, because of the square root, we also know that we cannot take the square root of a negative number, because if we have that, we have a complex or non-real value, and we're only talking about the set of real numbers. So we're going to combine those two facts to say x plus 1 must be greater than 0. So that takes care of those two situations. It's not equal to 0. We said that in the inequality. And by setting it greater than 0, we're defining x plus 1 to be positive. Now we solve that inequality by subtracting 1 to both sides. So we have x is greater than negative 1. Now we're going to write the domain of this function in two different ways. The first way is set notation. So we're going to open a brace. Sorry, that's a terrible looking brace. And we say x is such that. So that vertical line segment means such that. Here, next, we are going to define what x is or what x is not using inequalities. So we say that x is greater than negative 1, and then we're going to close the brace. We can also define this using interval notation. So x is greater than negative 1 means that we have the interval starting at negative 1. We are not including negative 1, which is why we use a parenthesis there. Because there is no upper bound to this interval, because it doesn't say x is less than anything, we say it's unbounded, so it goes up to infinity, and we close the interval with a parenthesis around infinity. So that would be your interval notation. Now let's go to our second example, where we have f of x is equal to the square root of x minus 7 over the expression x minus 9. We have a similar situation where we have two different things we need to consider, but we're actually going to consider them separately, unlike the first example where we had to almost combine them together. So what we know is that x minus 9, again, cannot be equal to 0 because we cannot divide by 0 or have a 0 in the denominator of a ratio. So we're going to set x minus 9 equal to 0, solve that, and we get x is equal to positive 9. Therefore, positive 9 makes my function undefined. So now we're going to come back to that here in a minute. We're not done. We also know that we cannot take the square root of a negative number. So we know that x minus 7 must be greater than or equal to 0. So we're going to solve that inequality to get x is greater than or equal to positive 7. We're now going to combine both of those into our set and interval notation. Let's start with set notation. So what we have is a brace where we have x is such that x is greater than or equal to 7, comma, but x cannot be equal to 9. Close brace. So again, we use inequalities to define the values that x is allowed to be or that x is not allowed to be. Now for interval notation, we're going to start with the lowest value that x is allowed to be, which happens to be 7. Because x is allowed to be 7, we are going to use a bracket around 7, and we're going to go up to the value that breaks our interval, and that happens to be 9. Now, it's not allowed to equal 9, so we use a parenthesis there. Now you have to decide, are we stopping at 9? Is it allowed to be any value larger than 9? And the answer is yes, because x is allowed to be anything larger than 7, just not the specific value of 9. So we're actually going to pick up with 9 and go up to infinity, because after 9, it's unbounded. But notice a parenthesis around 9 because 9 is not part of our domain. So that one's a bit tricky, where you have these two separate things you need to consider, and we're going to put them together in the set notation or interval notation, rather than the first one where we had to combine them together in the inequality, the two different situations happening. All right, guys, good luck.